All right, I'll be just a second getting up. As always, I have to professionally test my mic. In other words, I have to wait for the YouTube to catch up on my phone and then see if it's picking up on the mic. So thanks for being here. Tonight we're going to talk about discrete probability distributions again, specifically the binomial. We're going to do some examples from there. And I am up and going, and it is good to go. So I'll just put that over there. So we're going to talk about binomial distributions, how to build the table from them, how to find the probabilities. Has a special formula with combinations and some other pieces and parts that we derived the other day in class. We're going to talk about that in terms of what you will need for the assessment. So we have a test tomorrow, and I just wanted to do a second review and just work through some problems. If folks from my class are unable to be here tonight, it's okay. Not a problem at all. This video will be up video on demand, and hopefully it helps you a little bit. I'm always looking for feedback from my students, whether this is helpful or not. If there's ways to make it better, I certainly want to know, even if it's just for you, because it might help me change a few items here and there as I move forward. All right, so discrete probability distribution. So let me swipe through here. Let me kind of readjust my desk. I have a very small desk, or normal size desk, I guess, not super small. So we talked about this during the last video that I did last Thursday. I'm not going to run back through that. I will talk about it just for a second. I will look at this because this is very important. The summation of the probabilities must always equal 1. This one plus this one plus this one. No problem there. We've run through this in class often enough. I think we're okay. We've run through this on these videos often enough. I feel like you're okay, and I'm sure you've run through it on your practice problems in the MyStatLab. Summation of the probabilities equal 1. And keep in mind, we talked also quite a bit that once in a while, if you round or if you truncate the numbers off on one end or the other, well, on one end, on that right side, then you may come up with something that is almost 1. But you can explain it. As a researcher, you stand in front of people, you say, this became this because I rounded at this point in my computations. You could also have 0.9998. That would still be okay. As long as you know that you have derived those numbers correctly and you're not vastly off, then you're probably right there in the ballpark. All of your probabilities, no surprise there. This one, and this one, no matter how many there are, they all have to fall between 0 and 1. It's that range of probabilities rule that we study with basic probability. So even with the distributions, that never changes, stays the same throughout. If you want to find the, and I did not put, but this is the mean. If you want to find the mean of a regular discrete probability distribution, the kind that we've worked with, where we're given some frequencies of occurrences, and we take those frequencies and build a frequency table, and then from that table, or we have a frequency table, and from that frequency table, we build the probability distribution table. At any rate, when you get the distribution, you find the mean by using this formula that we also derived in class. Summation of x times the probability of x. We also walked through quite a few times with the calculator on how to pull out these numbers very easily on the calculator. I'll talk about that again tonight. Let's see. Last but not least, we'll switch colors to red, and this is the variance. No need to have another formula for standard deviation because the relationship between the variance and standard deviation stays the same. In other words, if you take that variance and take the square root of it, you got the standard deviation. Excuse me, so I did not insert that into my keynote presentation. So just a quick review on that. I do want to walk through one problem of this. I'll see how long it takes me to get through the binomials. If it takes me a little bit, then I won't come back to this. Let me just show you real quick. I have solved the calculator dilemma. I don't know if any of you have watched my videos at all. Maybe not. Maybe I'm the only one that makes them and watches them. But the calculator, I had a new fancier looking calculator. I figured out the dilemma with that one. The numbers were so tiny. The same thing was up with this one. The numbers were so tiny, but if you notice now they're not so tiny. If I go second vars and I go to binom PDF, it's not so small. You can actually see it on the screen. So I solved that dilemma, what I thought was a dilemma anyway, of not being able to see it. In other words, on your screen, I want you to be able to see what I'm walking through. So let me scroll back up to main where I just was. And we'll go back to the calculator page when I get there. I'll just say this. I screwed up my screens here on Ecamm. I do love Ecamm a lot, especially now that I've pulled everything off of my Mac and I'm just pushing things through Mirroring 360. He's Mirroring 360, yeah. A very cost-efficient program that I've used quite a bit now here lately. But now that I've pulled everything off, I really like this a lot. But I went in there and I was screwing around with my pages and I messed them up a little bit. But I think I'm slowly getting them back. So anyway, let me walk through. Nope, we're not doing that right now. No. I don't know why it's doing that. Okay. So what we're going to talk about tonight is binomial distributions. And as always, I just have some information up here, most of which, actually all of which we've covered in class, not most of which. If you see right up there in the upper left-hand corner, did that mark? Yes. In the upper left-hand corner right there, the binomial experiment is a probability experiment that satisfies the following conditions. We've talked about these conditions quite often. Number one, does it have a fixed number of trials? Does it have the same probability throughout? Are there only two successes that could occur with each event? In other words, a success or failure. That's all we're looking for. You can't have a multitude of things happening. You can't have changes in probabilities. So there's only two possible outcomes of interest for each trial. Oh, you know what? I must have taken a picture of that when the mouse was there. Anyway, probability of success is the same for each trial, and the random variable x counts the number of successful trials. So what we're trying to, the probabilities are towards a success in whatever we're looking for. If we're looking for the number of dogs in a household in a certain populated area, then that is our success. Finding dogs would be success, or not finding dogs would be success. But whatever we find is going to be what we label S. The symbols down below, in class, I don't know that I focused a lot on the symbols. Typically, I write them out. I always go back to taking physics in undergrad courses. Every time you take a physics class, you start drawing a lot, and you start putting the data that you have over to one side, because that's the data you have right now. That's the initial velocity, initial position, blah blah blah. Same thing here. You just write it down so you have it right there next to you. And I do that because if you look back into the problem itself and try to pull it out every time, you'll ultimately grab a wrong number somewhere down the line. You certainly don't want that to happen on the test tomorrow night. This bad boy right here, very important. I'm going to work with that tonight. We're going to talk about that. Again, we worked with it the other night quite a bit. And then we're going to talk about this, finding the mean, variance, and standard deviation of a binomial distribution is a whole lot easier than it is for finding it for a regular distribution. Neither are hard, neither are rocket science, but this is just a little bit easier to deal with. So let's get started with the first problem. All right, so mean, variance, and standard deviation. What we're going to do here is we already have some information. We need to find the mean, the variance, and the standard deviation. So I'm going to work on my little chalkboard here. Okay, so we will start with 13. So we've got n equals 50, p equals 0.4. So if I'm told that this is find the mean, variance, and standard deviation of the binomial distribution with the given values of n and p. So we're told it's a binomial distribution, and we're given the values of n and p. Well, if I want to find the mean, it's just n times p, which in this case would just be 50 times 0.4. None of these are too bad, actually. 50 times 0.4 accurately becomes 20. That's so easy. So for number 13, the mean for that is 20. If I'm looking number 13 for the variance, that's just going to be n times p times q. Well, we already know n times p, right? That's 20. and then it's going to be 20 times Q. Oops, I can't undo, yeah. NPQ. Well, if you know, let me draw over to the side. If you know what the probability of success is, in other words, if it's 0.4, then the probability of not success is going to be whatever's left is going to be 0.6. So don't get confused on one like this that might be on your test. Ultimately, somebody's going to raise their hand and say, oh, we're missing some information. Shouldn't we have that? No, you've got everything you need right there. Probability of success is 0.4. Therefore, the probability of not success or failure, however you want to say it, is 0.6. I undid too much. No problem. Times 0.6. And then I can just go to my calculator. So easy. 12. And then if I want to find the standard deviation, it's just the square root of 12, which is the square root of 3 times 4, which is 2 times the square root of 3 if you want to be mathematically correct on it. And then you can go in here, you can just say the square root of 12 on your calculator. That's more or less what I'm looking for. 3.46. Two times square root of 3, same thing. Okay. All right, so there we are. So there's number 13. No problem. Now the problem with working on Keynote is that I can only undo. So I have found the mean, the variance, and the standard deviation of this. Give me 1 second while I hit undo like 100 times. I think what I'll do is I will work through, I worked 16 now, I worked 13 now, I work 16. I'll just do 2 of these. Here we go. All right, so let's go to 16. No problem. We're given that this is a binomial distribution. We are also given all the information that we need. We're given that the number of trials is 316. We're given the probability of success is 0.82. All we need to find here is the mean, variance, and standard deviation. So the mean is just going to be N times P. Well, that's just going to be 316 times 0.82. Hey, Victoria, thanks for stopping by. Appreciate it. 316 times, what is it, 0.82? 259.12. Kind of scrubbed my 5 and 9 together there, but 259.12. So there's the mean of this binomial distribution given this type of example. Next, we will go with variance. And the variance is just simply, because this is a binomial, NPQ. Well, N and P was 259.12 out to 2 decimal places. Actually, it terminated to that. I didn't round it or anything. And now I'm going to multiply that times my Q. Well, remember, if my P equals 0.82, then my Q, complementary-wise, is what's left to get to 1. And that's... See, I messed up my screens. I had myself as a little circle down at the bottom. Let me just redo this. If the... Oh, my gosh. If the probability is equal to 0.82, then Q is what? 10 plus 8, so it's 0.18. Got it. That's no problem. And now we can see it. And now I go back to green, so N times P times Q is going to be 259.12 times 0.18 times 0.18. So I just put it in my calculator. 40. I got out to 3 decimal places, 643. So it's 46.642, not 3. 46.642. There we go. Big head was in the way. I don't want to move it because I got some other stuff. I try to leave it consistent. So, okay, so there's that. And the relationship between variance and standard deviation remains the same. There we go. The Standard deviation is nothing more than the square root of whatever the variance is, which is the square root of 46.642. 46.642. 6.83. We'll just go out to 2 decimal places. So I got that. I got that. That should be 1 decimal, just 1 little dot there. Okay. Yep, mean, variance, standard deviation. Done. So I worked 2 of these types of problems. So here's a type of problem that you'll see. And remember, when I do these reviews, these are not everything that you'll see. But I want to give you, it's probably 65-70% of what you'll see is what you see in my reviews here. And there may be a couple of stumper problems, but nothing to trick you. Just some to challenge you a little bit on the assessment. All the stuff that you already know, you just have to apply it. If you remember in class, I told you probably the hardest thing you'll have to do with probability distributions is determine whether it's just a regular frequency distribution, where we're trying to pull the probabilities out given some frequencies. That's a regular probability distribution, and the mean, variance, standard deviation are different. The binomial, you have to fit the constraints. Is there a fixed number of trials? Probabilities stay the same for successes all the way through. Are there only 2 outcomes of interest, success and failure? If that's the case, then it's a binomial, and you can apply the binomial probability formula. All right, so there's that. That's my warm-up, by the way. That's the starter. Yeah, that's it. Okay, now let's look at this one. Cold turkey. I haven't looked at this one today. So you are taking a multiple choice quiz that consists of 5 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess the answer to each question. Find the probability of guessing exactly 3 answers correctly, at least 3 answers correctly, and less than 3 answers correctly. Okay. So first of all, what type of probability distribution is this? Hey, Artemisia. Thanks for coming by. I'm in problem 2, by the way. I just finished one that looked like this, and now we're looking at one on multiple choice quiz. And again, these are the types of problems you might see, but I'm not limited to just these. There may be some additional ones on the test. So don't get mad if there's something on there that wasn't in this. But I am pretty good at aligning everything with what we've done in class. So if there's ever one that is on there that slipped up and got on there, just raise your hand and come see me, and I'll let you know real quick if that's really one that shouldn't be on there or if it's okay. All right. Multiple choice quiz consists of 5 questions. Okay. So what I need to do here is first I'm going to determine whether this is a regular probability distribution or a binomial. I think it's binomial right off the top because I have a finite number of trials. We have 5 questions, so n equals 5. Okay. Each question has 4 possible answers, only one of which is correct, which means the probability of success is 0.25. You take a multiple choice test, there's only one multiple choice answer that works in most of the problems. In this one, it's for all of them. The probability of randomly selecting the correct answer to each one is 25%, which means that your probability of failure would be 0.75. And yeah, that's all we need. So we're going to build the table here. Sorry, it took me a second to figure out what I was going to do here. So we've got the random variable x, which represents the number of correct answers that you guessed, the number of answers you guessed correctly. That's what the value of x is. And then we've got the probabilities down here. Well, there is a chance that you got 0 of them right. One second. Because I'm mirroring here. I did bring that right down there, could I? If I had to. Sorry. Brainstorming while I'm moving, just moving to another screen. Okay. So all of a sudden, Q is not showing up there, but it's showing here. Give me 1 second to troubleshoot this. When I'm looking on my stream too, it's not showing Q, but Q is definitely written in there. So let me do this. Let me stop mirroring. Let me mirror again and bring it back up and see if that takes care of it. I'm sure it has something to do with my little glitch there where the other iPad went down. Looks like I'm going to have to write all of it again, no problem. Oh my gosh. As you can see, as excited as I am about screen mirroring, I still have some little glitches because I have a couple of other screens over here that I move everything to so I can maximize it. Let me just rewrite this. Take a multiple choice quiz, consists of 5 questions. N equals 5. Okay. The probability of success, because there are 4 answer choices, the probability of you guessing the right answer is 25%. The probability of not success or failure, however you want to look at it, is 0.75. I'm not going to write the value of the random variable x because it's going to take too much room, but the value of the random variable x takes on the value of the number of successes in these 5 questions, which means I gotta watch that because my head's there. I could possibly take this quiz and get 0 correct. I could get 1 correct, 2, 3, 4, and 5. I think I got plenty of room there. Okay. I need to find these. Okay. I'm going to write down at the bottom what most people don't want to see. And then I'll pull the calculator up and we'll look at it using the calculator. But I am going to walk through this. We talked about in class, derived a formula that we went through computationally in class that looks as follows. And what is it we're looking for? Time out. Exactly three answers correctly. So let's look for that one. So I'm going to go, what's the probability that I get exactly 3 answers right? Okay. Well, that's going to be n factorial over n minus x factorial times, put a little x instead of a dot, the probability of success to the x value times the probability of failure to the n minus x. Okay, no problem. Can we work with this? Yes, all day long. Let's do it. Let's just set up let's just set up the numbers if nothing else. So I've got 5 times 4 times 3 times 2 times 1 on top. Would you agree with me there? That's my factorial. On the bottom, I've got right here, I've got n minus x. Our n is 5. Our x value in this case is 3. So I've got 5 minus 3 is 2. So I've got 2 times 1, no problem. And then I also have x factorial, which is 3 times 2 times 1. Remember your teacher used to teach you was canceling, which is always confusing. What does that mean? Make people think it goes away, but really it becomes 1. So there's a 1, there's a 1, there's a 1. They cancel out in the sense that it's an understood 1 now. And on top, I've got 5 times 4 is 20, and I got 2 times 1 is 2. So overall, I've got a 10 there. Okay. Probability of success is 0.25. So times 0.25 to the 3rd power times 0.75 to the 2nd power. Enough room? Yeah, barely. Okay. So I'm gonna test this theory on my calculator. Matter of fact, didn't I bring this? Yeah. Look at this. Look at that guy. Okay. So I'm going to clear it. Notice I made some changes. It's bigger. We can see it. I'm very happy with that. I didn't realize that I had those options. This $4.99 is paid off for this calc. 20 divided by 2 is 10 times 0.25 caret 3 times 0.75 caret 2. And there it is. So what I get right here is 45 divided by 5. This calculator is better in this respect. It pushes it out as a fraction and then shows all of it in one. I don't even have to hit enter, and there it is. So I'm looking at this as equals 0.08789. If I want to take it out that far or whatever, I will. So 0.08789. Great. Okay. Now, let's go back to the calculator like we did in class, and let's solve this and check my answer. All right. So I'm going to clear all of that. I've already written out the answer. And if you remember, we stated this was a binomial distribution. It seems to fit. And so I'm going to go second vars to the distributions. Now, this looks slightly different than your calculator, but it's the exact same. This calculator has just put in some syntax and stuff for you to follow, and just has it looking slightly different. That's the difference in this calculator and the other one that I had been using. Is that, in fact, I'm going to flip back to that one in a second, and I'll show you, because I want to remind myself too. You go down here to binomial PDF, because we're looking at one single instance. We're looking at the probability that we have exactly 3 successes in this experiment, probability experiment. So it's NPX. So the n's are 5. The syntax is NPX. The probability was, what, 0.25? Probability of success. Look at that. It's already given me all of them. And then we're just looking for 3. Same thing. But look at this. This is exactly what this is a better calculator. There it is. So I've got my numbers right there below for my entire table. So the first one is 243 divided by 1024. 0.237. That was for 0, right? Yeah, 0.237. 0.237. I'll write it sideways. For 1, it's 405 divided by 1024. 0.396. 2 is 135 divided by 512. 0.264. Right. 45 divided by 512. 0.088. Whoops. 0.088. Just wrote it wrong. 15 divided by 1024. 0.015. So 0.015 at 4. And then at 5 is 1 divided by 1024. 0.0009. Good enough. There we go. Okay. We have just built the table using our calculator. Now, what I'm going to do right now is I'm going to bring up my other calculator, if I can find it. Should be right there. It is. Bring up this calculator. Now, when I go second vars here, notice this looks a whole lot more like your calculator. So I'm still kind of split between the two calculators. And when you pull out, oops, the binomial PDF here, it wants you to use the wizard. And when I go to mode to get rid of the wizard, I can't find how to get rid of the wizards. So anyway, kind of back to this one. This is a basic. I like it better. There it is. Okay, so let me move that out of the way. So there's the first example worked for a binomial distribution answer guessing. So I built the table from the calculator. I worked one out using the form that we have derived and used computationally in class, right? That's a combination times probability of success to the value for the random variable x that we're looking for, et cetera, et cetera. So now what we need to do is we need to find, there's more to this. It wants us to find the probability of exactly 3 answers correctly. Well, we did that. That was right here. And we did it. I got it down here in a very long form, and then on the calculator. So there's the answer to that first one, to A. At least 3 answers were correct. At least 3 means that 3 is the least number that you've got. So at least 3 means here, here, and here. So I just add those 3 together. So I got 0.088 plus 0.015 plus 0.0009, and I get 0.1039. So the probability of at least 3 equals 0.1039. So that's the answer to B. And now when you look at C, less than 3 answers correctly, where less than 3 is not inclusive, it's not including 3. So it's just, what color have I not used? Blue, but blue doesn't show up. Let's use red. So you're going to use this one, and this one. So the probability that you get less than 3 answers correctly is this one, and this one added together. So I'm just going to leave that. You just add those 3 together, and that's your answer. All right. I've run out of room. If I had my regular dossier, I would be able to erase and move and kind of do stuff, but on Keynote it doesn't allow me to do that. So I have to figure out that dilemma. Okay. All right, no question. I don't see any chat or anything, which is okay. So what I'm going to do now is move on to the next one. I think this is the last one I've got. Yeah. This is the third. Oops. This is the third one. So the stream seems to be going, but okay, sorry. My stream on my phone, I told you this is a very professional setup. I basically just look at my phone to see how it looks on YouTube or on Twitch or wherever I'm streaming to. All right, surgery successes. A surgical technique is performed on 7 patients. You are told there is a 70% chance of success. Find the probability that the surgery is successful for exactly 5 patients, at least 5 patients, and less than 5 patients. So it's basically similar to the one before. You could easily do a tree diagram here if you needed to. We don't need it for this. But this is a binomial. Again, you'll have to recognize this is a binomial, not a regular probability distribution. And what I will do is I will draw across the bottom so I got enough room. So here's my probability distribution table. My values that I'm working with, n is equal to 7. Surgical technique is performed on 7 patients, so we have a finite number of trials. You were told there's a 70% chance of success, which means there's a 30% chance of failure. So you've got probability of success is 0.70. Probability of failure is 0.30. I'm not going to write out for the other because I'm going to use my workspace. Remember, it's not dossier. Okay, so I'm going to start my table down at the bottom, then I'll pull the calculator down, and we'll work through it we'll work through this one with the calculator, just with the calculator itself. But remember, if I wanted to, like for that first one, exactly 5 patients, I could go probability of 5 equals n factorial n minus x factorial, because we're working with a combination, then x factorial, my little dots aren't showing, there they are, times probability of success to the x power times probability of failure to the n minus x. There it is. Okay, we could use that if we wanted to. We're going to use the calculator. Is there a chance that on these 7 patients, none of them are successful? Yes. There's also a chance there's 1, 2, 3, 4, 5, 6, and there's also a chance that all 7 of them are successful. So I've lost my mouse. There it is. Look at that. Beautiful. Okay. Good thing is I can shift this around, I suppose. So I'm going to find 0, 1, 2 to start with. So I'm going to go to clear. I'm going to go to second vars. I'm going to go all the way down to binomial PDF. And the syntax is in, the syntax for this looks like this. It's binom PDF, and it's binom PDF, and it's in P and then the specific value of X. Now, if you instead of putting that X out there looking for the specific value, if you just put n/P and then store it in L1, you can easily see it. I'm going to do that with this one, even though this calculator that I bought through Apple does show the values, shows them as fractions. We can work with that, but I'm going to save it. I'm going to store it to L1 like you would on a regular TI-84 in class. Okay. Binomial 7 trials, comma, probability of success was 0.7. There they are. I'm going to leave it at that. I'm going to hit enter this time so that I have all my values. Wait. Clear. I think I hit it too many times. Second vars. Binomial PDF. We've got 7 trials. The probability was 0.7. Yeah, there it is. Okay. Hit enter. So that's the enter. I'm going to store these in second 1, L1. Okay, I just stored them. Now when I go to stat, edit, it stored them as fractions. Second quit. Let me do this again. I'm kind of learning this calculator as I go. This version of the calculator. Binom PDF. Because I had it set at fractions, that's why it keeps bringing it up as fractions, which is no issue, but I want it as decimal. We've got 7, comma, 0.7. Enter. No problem. Store. Second. L1. Enter. Stat. Edit. There we go. Yay. So we've got some very, very small numbers here. So we've got 00022. 0.00022. You know that's very small. Hard to see and very small. 0.0036. 0.0036 for 1. Lost my place. 0.026. 3 successes, 0.097. 4 successes, 0.23. 0.32. 0.25. Sorry. And then 0.08. Okay. Now, let me move my calculator out of the way and we'll have all our values up there. I'll bring the calculator back in a second because we're going to work with cumulative. So there's all my values. So what I need to do is add these all together and make sure they add up to be 1. Make sure that I did stuff right. 0.00022 plus 0.0036. I could have done it on the calculator. 0.026, I just didn't. 0.097. 0.23 plus 0.32 plus 0.25 plus 0.08 equals. Okay, good example of what we were talking about earlier. I rounded on all of these all the way across. So the summation of my probabilities is equal to 1.00682. Part of it's underneath my head. So my summation of probabilities is 1.006. You see there that we've got a larger number than 1, but I rounded. I made those numbers change. Excuse me, through the rounding. Good as gold for me. That's fine. All right. Now, the probability that the surgery is successful for exactly 5 patients, right there. No problem. And by the way, that would look like the following. Let's see, the probability of 5, and you put 0.32. Okay, but that's the answer there. At least 5 patients, which means the least value you can have is 5. So at least 5 patients is going to be the 5. Hey, Tiante, thanks for stopping by. The 6 and the 7. So you're going to add this one, and this one as the table gets messier. And then the last one that we're looking at here is less than 5 patients. What color have I not used that I could use? Less than 5 would be not inclusive with 5. So it would be 4, 3, 2, 1, and 0. So I'd add that, and that. So I'd add all those right there. And that would give me the probability we've got less than 5 patients. And that is it. So remember, we've got this fancy dancy formula up here that you can certainly use. I like that formula. I like working through it. I like breaking it down into pieces. I like the pattern from it. But that's my preference. But we have worked towards after using that in class quite a bit, we worked towards using the calculator. And using the calculator on this assessment is fine. There's no issue whatsoever. So that was let's see, I have been on here. I usually stay on about 45 minutes, and right on the money, it's about 45 minutes, and I'm at the end of my problems. This will stay up there as video on demand. It's on my YouTube channel in the lives. I have them all packed together for the summer session. All the videos are in there together, and I started a couple of, maybe 3 weeks ago, putting dates on them so you can tell which ones they are by dates. That helps me too, because I get lost in the semesters and differences as that. Let me just backtrack for a second and go back. So, I don't know why it gets stuck here. The way I set up the keynote, I suppose. Okay, so we started off with just some generic information on binomial distributions. Make sure you know this. Keep in mind that you can use a 3x5 card for my test. You can put anything on there that you want to. My philosophy on that is 9 times out of 10, once you put everything on that card, everything that you think you need, you've typically committed it to at least short-term memory for the assessment. Oops. It helps. I'll go back to this. Some of the stuff that I wrote out here earlier is gone because it just kind of froze up on me. It helps if you write out your N, your P, your Q on the side. That way you don't have to keep looking at the context within the question. Very easy to look over and get the wrong number. If you notice as I'm working through this and typing in the calculator, you may not have noticed, but several times I glance up just to double check. Even though I have said the probability 3 or 4 times already at 0.7, I glance up again just to make sure that I'm putting it in right. This is the formula that we have used extensively. And this is finding the mean, the variance, and the standard deviation, which on that last one I did not do. But we had done several problems like that prior to. So, right here. So I did number 13. And I did number 16. And we worked that out. I had all the work up here. Again, it froze up on me, so I had to start over. Then when we go here, we did answer guessing. There's that, look at that artwork, beautiful. We walked through this step by step. And this, of course, is up on video on demand. So if you missed pieces of it or you didn't have a chance to show up tonight, it's fine. It'll be on video on demand. Just kind of go to where you need it. And if you have any questions past that, by all means, send them to me through email. Surgery success. I just walked through that one. We successfully walked through that one without the formula, which we used the formula for at least one instance here and walked through it. But on this one, I wrote the formula up in the upper right-hand corner, and then I worked it with the calculator otherwise. And that's it. That's where I'm at tonight. So I did tell you that last Thursday I would do a probability, some probability problems from chapter 3 in the text, and the probability distributions I said I would do tonight, and so I've walked through it. I actually walked through I think probability distributions last Thursday. I don't know, I'm getting confused now, but I've walked through them. I've gone through some stuff, and take a look at it. Go back over your work. Make sure that you go back into the MyStat Labs, take a look at what you can in there. And then we have a test tomorrow. I don't think it's going to be a hard test for you, but do study and take all the time that you can on it, and I will cover a smidgen on normal curves, and then I'll give the assessment. This is July 4th week, so I probably will not hold you for a ton of hours. So we'll take our test and then roll after that. So that's all I've got. So thanks for coming by. I appreciate it. I also appreciate folks who come by later. If you get a chance to subscribe to the channel, I am trying to put up videos from time to time with the calculator stuff. I'm slow going with that because I have a day job, so to speak. I'm working through the day. So I do try to put those up when I can, and I will try to put up some different computational type videos that are a little more than just walking through it like this, that'll probably hit the mark a little more clearly. So that's all I got. All right. Thanks for coming by. I appreciate it, and I will see everybody in class tomorrow night. Thanks.